Hello, Matthews Gatos here. In this chapter 6, lesson number 5, we're going to introduce sinusoidal functions, and in particular we'll talk about the amplitude and the period. You'll notice that we did not do lesson 4 because it is not part of the curriculum. You do not need to convert between degrees and radians. Everything we will be dealing with will be in radians. So let's talk about periodic functions, because sine functions are periodic. Periodic functions are any kind of a function whose graph regularly repeats over some interval in the domain. Now, the length it takes to go through that repetition or that cycle is called a period. So period is the time it takes the graph to go through one full cycle. In terms of sine, we're talking about the time it takes to go through a hill and a valley. So for example, the time it takes to go through a hill and a valley. Or we could say the time it takes to go through a max to max, so from a maximum to a maximum, or a minimum to a minimum, minimum to a minimum. Okay, or again, one hill, one valley. You'll notice that all of those are horizontal distances. So I'm talking about the distance along here, or the distance along here, or the distance along here. So it's a horizontal distance. So to find that, we're going to use x values to find the period. Now, amplitude is the height of a graph from the middle of the graph to the highest point, or middle to the lowest. We can use this formula here, max minus min divided by 2. So to figure out the amplitude, what we're going to do is look at where the halfway point of the graph is, and we are going to divide it by 2. So if we look at our graph, let's say like this is going to be a sine graph. So from the middle of the graph along here, I'm looking at the distance from the middle of the graph to the maximum, so this distance here, or from the middle of the graph to the low point. Or you could take the distance between the max and the min and divide that distance by 2. So whichever method you like to use to find that, you'll notice this is a vertical distance up and down, so it's going to affect my y values. Okay, so let's just practice finding the amplitude and period for the following functions. So in this function here for a, I want to look at a cycle here, and I see it's like a hill and a valley. So if it starts at a hill and a valley at the origin, so hill and valley, the period is where the valley ends, which is right here. Okay, so in this case here, the period will be 8. Let's figure out what the amplitude is. So I'm going to use my formula, max minus min divided by 2. So I have a max point at 10. I have a min point at negative 10. So to find out what the amplitude is, let me just make that a little neater. There we are. So the amplitude is going to be the maximum point minus, in brackets, the minimum point divided by 2. So that's going to be 20 over 2, which is just 10. So I have the period is 8, and the amplitude is 10. Let's look at the next one. So for this one here, my tip for you in math as well as in life is to stay positive. The reason I say stay positive is because I am not starting right at a max or a min. So I'm going to count max to max or min to min to the right of the origin. I'm not going to focus on the negative part because it'll be easier for me to count. So again, let's look at the period. So I'm going to look at a maximum point to another maximum point. So remember, that is a horizontal distance, so it has to do with your x values. So the distance between 3 and 9 is 6, which makes my period 6. Okay, looking at the amplitude. Amplitude is a vertical distance, so we have to look at our y values. So it is maximum, which is 6, minus minimum, which is negative 2, divided by 2. So let's put that into our calculator. So 6 take away negative 2. Oh, goodness gracious. Here we are. There we are. Divided by 2. So that's 8 divided by 2. My amplitude is 4. So I have my amplitude and my period for both. Okay, now I said we're not dealing with degrees, we're only dealing with radians, so I just want to go back and review pi. So introducing pi. You guys know this is a symbol for pi, and most of us, when we think about what pi is, we think about 3.14. Interesting fun fact, if you actually take pi, 3.14, and reflect it in a mirror, you literally get pi. try it out if you don't believe me. Okay, so 3.14 is not really accurate. It's an abbreviation. If you look at this, for example, here's 453 digits of pi. That's just 453 digits. But pi is an irrational number, which means it's Buzz Lightyear. It goes on to infinity and beyond. So there's really no end to pi. Well, how is that going to help us with sine graphs? So when I'm talking about pi, I am talking about 3.14, but there's another thing I'm talking about. In trigonometry, we know that pi is the ratio of the circumference, distance all the way around a circle, divided by the diameter. In terms of angles, here's what it is. If I were to take, using my protractor, a 180-degree angle, so there's 180 degrees, that is also a representation of pi. So 180 degrees and pi are the same thing. So there's another thing that you can add to your knowledge of pi. It's not just 3.14, which up here is found by doing the ratio of circumference over diameter. Pi is 180 degrees, and this is in terms of angles. So whenever you see pi, we're talking about radians, and that's all we're going to use in this chapter. We're not going to use degrees, we're just going to use radians. Now those radians might be pi's, or they might be numbers. So if we think about pi radians, pi is about 3.14, pi is about 3. So I could also use a scale going like 1, 2, 3. Or you'll see some questions where we use intervals of pi. So just another way for you to think about pi. So if we look at this graph here, I want to find the amplitude and the period. Now, I know it's given a cosine graph here, but I want you to know this is just for amplitude and period. You don't need to know anything about cosine. So I'm just going to take that formula off there, and I'm just going to say find the amplitude and period of each graph, because we're not dealing with cosine, we're only dealing with sine, but it's still a good way to review amplitude and period. So again, amplitude is max minus min divided by 2. So I'll go in here and I'll identify my maximum of 1, my minimum of -1. So amplitude is max minus min divided by 2. So that's 2 over 2, which is 1. Okay, here's a little hint for you with amplitude. If the max and the min are the same number, just opposite signs, then the amplitude is the max. So see how it was 1 and -1? Amplitude is just the max. Can we use that on our next one? If you look at amplitude, max is 1, min is -1. Yes, so they're the same but opposite, so amplitude equals 1. Okay, so for this one here, I want to find the period. That's the length of time it takes to go through one full cycle. So here's my hill, here's my valley. So it looks like starting at 0, going to 2 pi, my period is 2 pi. Now I want to talk about scale. So looking at your scale, if you look at the scale, let me just erase what I've already drawn on here. So the period is 2 pi, but sometimes it's going to be off a little bit. So I want to talk about the scale. If you look from 0 to pi, 0 to pi, see how it is cut into 1, 2, 3, 4, 5, 6 pieces? Okay, well, we're not talking about that pi. I'm just trying to be silly. But this pi here is divided into 6 pieces, which means this is 1 pi over 6, this is 2 pi's over 6, this is 3 pi's over 6, 3 over 6 in lowest terms is 1 over 2, this is 4 pi's over 6, and this is 5 pi's over 6, leading to the full one, which is 6 pi's over 6. So whenever I want to look at the scale, I just look at what pi is cut into, and then I know that each little division point on my axes represents that piece of the pie. So think about pie, like apple pie, piece of the pie. Okay, for this next one here, I want to figure out the period. So I don't see a full hill and a valley, so I'm going to go from max point here at 0 to the other max point here at 2 pi. And again, the period is a horizontal distance between 0 and 2 pi. I get 2 pi. Okay, so let's explore the graph of a sine x. So these are all sine graphs, and sine is just based on that hill and the valley. So I want to know what happens when I change the number in front. So this one here really has an imaginary 1 in front. We just don't write it like that. Okay, we just write sine x. But just so you know, there is a 1 in front. Then we're going to look at what happens when there's a 2 in front and when there's a 0.5 in front. And you can see I've graphed them and I've labeled them all according to their color. So sine x is in blue, 2 sine x is in the red dotted line, and half a sine x is in the black line. Okay, so let's look at the amplitude. So you'll notice my little trick is going to help here because they all have same max, same min. Look at the blue graph. It has a maximum at 1, a minimum at -1. So remember, amplitude is your max. Let's go to my red graph. It has a max at 2, a min at -2, so same but opposite signs. So amplitude is your max. Looking at the black graph, it has a max of 0.5, a min of -0.5. So same but opposite signs, so amplitude is the 0.5. Okay, so it looks like your A value is lining up to the number in front. Look, amplitude of 1, number in front 1. Amplitude of 2, number in front 2. Amplitude of 0.5, 0.5 in front. Let's see if it affects the period. So the period is the time it takes to go through one hill and one valley. If you'll notice on these graphs, they all have the same start point at 0. They go through a hill. Now the hills are taller in some and shorter in others. They go through a valley, again, different heights, but they all end at 2 pi. So again, period is a horizontal distance from 0 to 2 pi. All of these have the same period. So it doesn't look like A is impacting the period. A is just that distance from the midline to the max or midline to min. A is the amplitude. It is also the number in front of sine. Let's add that. Also the number in front of sine. So it's the number in front of sine x. Uh-oh, my dogs. Hold on. Okay, I'm back. Sorry about that. Crisis averted. Let's look at this one here. The graph of y equals sine of bx. So b is the number in front of x. Again, look at what happens when there's no number in front. It's an imaginary 1. So I want to know, how are they the same? How are they different? Okay, so looking at your max and min, you notice that all these graphs, whether I have 1x, 2x, or 0.5x, they all have a max of 1 and a min of -1. So the amplitude is just the max, which is 1. So it doesn't look like your B value is affecting your amplitude because it's 1 for all of these. Okay. Let's figure out what the period is. So let's do the blue graph first. So blue graph is 1 hill, 1 valley. So it starts here and I come up, I come back down, and I end at 2 pi. So it looks for this one here, my period start to finish is 2 pi. Okay, let's look at my red graph now. So for my red graph, I'm going to do 1 hill, 1 valley. So I still start here. So I'm going to come up, I'm going to do a hill. Let me try that again. Come up here, do a hill and a valley, and I end at that point there. Okay, we got to figure out what that is by doing the scale. Now, they've given us the scale here is pi over 6. So each tick mark is pi over 6. Let's see how many cycles we go through, how many ticks we go through. 1, 2, 3, 4, 5, 6. So we go through 6 pi's over 6, which is just pi because the 6 cancels. So the period is pi. Okay, let's look at the black graph. I'm just going to erase these so we can see that a bit better. Okay, so if you look at the black graph starting here, it has a hill, but it doesn't have the valley. So you can see the valley is all the way over here. So this graph is going from -2 pi to +2 pi. So 2 pi to the left, 2 pi to the right, that's a total of 4 pi all together to go through one cycle. So it definitely looks like B is affecting the period. Okay, now B is not the period. It is the number of times the graph repeats itself in 2 pi. Let's check that out. Okay, if we look at the blue graph, let's erase all of this. From 0, I'm just looking at from 0 to 2 pi. So let's just highlight that across the horizontal axis. I'm just looking from 0 to 3 pi for each of those graphs. Okay, So if we trace through the blue graph, you can see one hill, one valley. I go through one cycle, and I had a b value of 1. So that looks good. B value of 1, one cycle. Let's look here. I have a b value of 2. So by the time I go from 0 to 2 pi, I have 1, 2 cycles. Yes, that also works. Okay, let's look at this one here, which has a b value of 0.5. So between 0 and 2 pi, you can see I have half a cycle, and that also looks right. So b is the number of times the graph repeats in 2 pi, not the period itself though. Okay, so let's tie this together here, period and amplitude. Amplitude is max minus min divided by 2, and period is 2 pi divided by b, b being the time that it repeats in one full cycle. Now, something to note about amplitude, if amplitude is ever negative, the amplitude is positive. The negative just shows there's been a reflection in the x-axis. Same thing with b. If the b value is ever negative, the period doesn't become negative. It just shows that there's a reflection in the y-axis. Okay, let's look at these ones here. I want to determine the amplitude, period, max, and min values. Okay, so for A, part A, if we look at this one here, A value is just the number in front of the sine x. So it's 0.5. Now I want to figure out what my max and my min are. So I have a little hint for that. So when A is given, the number in front of sine, and D is 0, in other words, I haven't added on a number here, max will be positive A, min will be negative A. So max will be positive A, min will be negative A. Okay, and then the period is just 2 pi divided by your B value. So here I'm going to have 2 pi divided by my B value of 0.5. So to figure out what that is, 2 divided by 0.5 is 4. So I'll just write that as 4 pi. 2 divided by 0.5 is 4 pi. So they want it as a multiple of pi and to 2 decimal places. So this is a multiple of pi. And then to 2 decimal places, I just put it into my calculator and say that the period is also about 2.09. Okay, so I have a new one for you guys to do for B. So just change your equation to be this one here. And let's answer all the same things. So amplitude is the number in front of sine x, which is 6. Now because there's no d added on, it's really like a plus 0, just like this one here was a plus 0. The max is your a value, the min is negative a. Period. 2 pi divided by your b value. You can see that your b value here is 8. So I'm going to have 2 pi over 8. So I just reduced the 2 over 8, which is 1 over 4. So my period will be pi over 4. That doesn't show up very well, does it? Let's try that again. So I'm going to write this as 2 pi over 8, and this is the same as pi over 4, because 2 over 8 in lowest terms is 1 over 4. That's as a multiple of pi, but I can also put that into my calculator, 2 pi over 4, or pi over 4, and get that my period is about 0.79 rounded. Okay, let's look at C. So again, remember that tip, when the number in front is A and D is 0, in other words, I'm adding on a 0, okay, I'm not affecting my max and my min. So remember, your A value is always just, your amplitude is just going to be 2. The negative tells you that there has been a reflection. So amplitude is never negative. Your maximum is going to be 2, your minimum negative 2. Okay, same thing with your period. I threw in a negative here so you guys could see that. So here the B value is a negative 0.25, but I don't use that for my period. I use just 0.25. So my period is 2 pi divided by 0.25. So let's divide 2 by 0.25. And when you do that, you're going to get 8 pi. So 2 divided by a quarter is really 8. So that's as a multiple of pi, and then I just put it into my calculator to get it to the nearest hundredth. So I can say that it's about 25.13. Not degrees. Okay, this is all radians. So don't throw a degree symbol on there. Okay, let's try this one here. So we have a partial graph of A sine bx. We want to state the amplitude and the period. Okay, so looking at the amplitude, the maximum is 3, the minimum is -3. Same value, opposite sign. Remember, amplitude is your max in that case. So amplitude is 3, A value is 3. Okay, let's figure out your period. So period is the time it takes to go through one cycle. So one hill and one valley. Remember, it's a horizontal value, so from 0 to pi means that my period is pi. Okay, so if my period is pi, let's just take this off to the side here. Period is 2 pi divided by b, so pi equals 2 pi divided by b. Well, if you think about it, they both have a pi on both sides, and to get rid of the 2 here, 2 divided by a b value of 2 would get rid of those. They would cancel to be just pi. Or another way of doing that is just to count the cycles from 0 to 2 pi. Okay, so now that I know my b value is 2 and my a value is 3, I can put it together in my graph and say that it is 3 sine 2x. And that would be my equation. Okay, now we want to graph this on our graphing calculator and determine to 2 decimal places the value of the function when x equals 5 pi over 6. Again, this is just an angle measurement. So I want to take my equation here and put it into y1, and this is an example of x given, y needed. Now when x is given and y is needed, we use trace. So that's what I did here. Okay, so I entered my equation in, I did trace of 5 pi over 6, and when I press enter, I can get the value, and it's a y value, and they want it to 2 decimal places, so I can say y equals -2. That would be 60, because it's 59. So I'll just write it as 60 because they want 2 decimal places. Okay, the next one. Find the values of x between 0 and pi for which f of x is 1.5. Now, f of x is just a y value. So this is an example of y given and x needed, but only between 0 and pi. So the only way that I can get x values is by putting the y value in y2. So that's what I do. This is a y1, y2 intersect. So I put it into my calculator, and I'm only looking between 0 and 3.14. So the only 2 answers that worked were this one and this one, because this one here was too much. In other words, it was bigger than 3.14, and I only wanted it between 0 and pi. Alternately, I could set my windows so that between 0 and pi, I could set it so that your x min was 0 and your x max was pi. That's totally fine. Okay, so I did that, and I get an x value of 0.26 or an x value of 1.31. Oops, lost my pen. 1.31. Now, I do want to mention that there's a window setting in your calculator that is really useful for this. I'll just show you really quickly. If I wanted to enter in 3 sine 2x into my calculator, so your calculator right now should be in radian mode because you've reset your calculator so many times, but I just want to make sure that it is. So if you go into your calculator, into mode, just make sure you're in radians. Okay, so if I go into my y equals, let's just clear out what I was working with, and I'm going to enter in the equation 3 sine of 2x. So I just want to show you something about the windows. Okay, so was that my formula? 3 sine 2x, yes. So because you're already in radians, you don't even have to worry about the windows if you use this little trick. If you go zoom and you go down to trig, see zoom trig 7? It sets it to a standard window setting for trig, which is what we're working on. And there we go. It does a nice little window for you. Okay? So zoom 7 is a good window setting for you to remember. Let's just open this up and write that down. So zoom 7 gives you a nice trig window setting. Okay, let's look at this example here. The partial graph represents the sine function. f of t equals a sine bt that has a minimum value of 3 and a max value of 3 and a min value of -3. So they say that because you can't really see the minimum value. So since the max and the min are the same but opposite signs, the amplitude is the max. Okay, so let's figure out the period of this graph. Okay, so what we're going to do is we're going to find out the period, and then we're going to use our formula to help us. So if we look at this, I have one hill, and that takes me to 6. I only have one hill, but I know that the period is one hill and one valley. Okay, so if the hill is 6, the valley also has to be 6, and the period altogether must be 12. Okay, so the time it takes to go through the hill is the same time as it takes to go through the valley. So what I can do is I can use this formula here, 2 pi divided by b, and I know that, oh, b, not p, 2 pi divided by b. I just want to show you another trick in a minute. So I'm using this formula here. Period is 2 pi divided by b. So if period is 12, 2p divided by b, you can solve for b by multiplying both sides by b, and then I get 12b equals 2 pi, and then to solve for b I could just divide both sides by 12, and then I would get that b is 2 over 12 in lowest terms is 1 over 6. Okay, so that could be your b value, so I know it's pi over 6. Or here's a little tip. The formula you're given on your formula sheet is period equals 2 pi over b, but you could just switch the 2 pi, or the period and the b around, as long as 2 pi is kept on top. Let's try that. Period is equal to 2 pi over my period, which I said was 12. If you look at this, 2 over 12 in lowest terms is 1 over 6. So that looks like it's an easier way, but whichever way you want to do it is fine. Okay, so my period again was 12, and my a value is 3. Let's put that all together in your equation. 3 sine of pi over 6 t. That would be your formula. Okay, so to summarize, a is your amplitude, always a positive value, and it's a horizontal distance, vertical distance, let's add that in. It is the vertical distance from the midline to max or midline to min. B is used to find the period. It's not the period. It's the number of times the graph repeats itself in 2 pi. So period is always going to be 2 pi over b, and we can add to it that formula that I said you could also use. B equals always 2 pi on top. B is equal to 2 pi divided by the period. So that will always work. Okay, I want you to think of Ace of Base's song, I Saw the Sign. I saw the sign and opened up my eyes, I saw the sign. And the next time you hear that song, I want you to think of this. I saw the sign curve. Okay, you guys can go and do practice questions 1 to 11. Detailed solutions for those are on D2L. I hope this video helped, and I'll see you for the next one.